Now let's look at how to find limits on equations. Knowing what the graphs look like for different functions, that's really going to help us to figure out how we want to find the limit. One note on this first example, if the equation gives us a continuous graph, meaning there's no holes, there's no jumps, it doesn't skip anywhere, then we can simply plug in x for the value, because what it's approaching, it would be what the function value is. So they're continuous within their domain. For this first example, we want the limit as x approaches 3 of 2x squared minus 5. Well, we know that that's a quadratic because of exponent 2, so it would give us a nice little parabola somewhere. So no matter where our x is, it's going to be approaching that y value. So we can simply plug in that 3 for our x and get a limit of 13. If the function is not continuous or defined at your quote-unquote a, try to reduce and see if you can find the limit of the simplified function. For example, e, they're asking for the limit as x approaches 2 of x squared minus 4 over x minus 2. Well, we know it's not defined at 2, but we could take the top and factor it, x plus 2, x minus 2, and notice that the binomials x minus 2 reduce. Now, when this happens, when it reduces, that creates a hole at x equals 2. And so we would be left with just this linear function of x plus 2, which means it graphs like a line, but it just has a hole at x equals 2. In other words, it would still approach the same y value as x plus 2. So that means the limit as x approaches 2 of that rational function would be the same as the limit as x approaches 2 of the linear equation x plus 2, which when you plug in the 2 would equal 4. So notice in example F, it's actually approaching 3, and it's defined at 3. I can plug in 3 down here, and we get a 1, not a 0, so we can just plug it in. But let's say again, for example, it was 2, approaching 2 instead of 3. We would still need to factor the numerator, which would factor into 3x plus 4 times x minus 2, all divided by x minus 2. If you're having trouble with the factoring, be sure you watch the review videos on factoring. That will really help you during this section. So the x minus 2 is reduced, leaving us a hole at 2, but the limit as x approaches 2 would be the same as the linear equation 3x plus 4. So if we plugged in 2 for the x, we would get a limit of 10.